Welcome all of our participants that are joining us remotely. We want to thank you for jumping over to our keynote talk right now. I'll start off by giving some introductions and kind of slowly let people file in here to our keynote address. But first, I want to say that we have two wonderful keynote speakers as part of our symposium. And honestly speaking, we feel honored and fortunate that they would commit the time to it and be able to speak to the items that we are currently addressing in South Florida here and with the Lou Lab. So thank you for that first. We're humbled and we're grateful for all the people that have spent their day with us in the first day of the symposium, Wood and Everything After. And we look forward to everybody joining us for tomorrow's talks, which are track 2 and track 3, and then our last keynote speaker with Dean Peter McKee. So from that perspective, we want to add a couple logistical things as people are coming in. We want to share a reminder that our new guests might not have heard about our Miro space. We have a Miro space that's set up that has additional content and information in it. We'll be posting links and things like that come out of some of the talks. Some stuff came out of a couple of panels that we'll try to get in there so you guys have access to it or at least can view it. The space is pretty fun, we think, as an addition to the symposium in general. We have been fortunate enough to be able to acquire one AIA HSW credit for our keynote speaker tonight. If you would like that credit, please email the Lou Lab at the Littoral Urbanism Lab at miami.edu. We'll put that email in the chat. And in the subject line, please provide us with the subject AIA credit, Wood and Everything After Symposium. You'll need to put in that email as well your AIA number and your name so that we can pass that on to the people that need to get it. Okay, so let's kind of get in here and get going. So it is with great enthusiasm I welcome to the virtual stage Alan Organschi, principal of Gray Organschi Architecture based in New Haven, Connecticut, and a senior design and technology faculty at the Yale School of Architecture, where he directs the Yale Building Lab. Among many honors, awards, and recognition, Gray Organschi has received an emerging voice in architecture by the Architectural League of New York, multiple American Architecture Awards, and honored with an Arts and Letters Award in the Architecture by American Academy of Arts and Letters. In addition to Alan's practice and his teaching role, he is the founder of a fabrication and construction management firm, JIG, or JIG Design Build, and a research project, Timber City Initiative, examining the applications of wood fiber in the construction of our cities. Timber City has received financial support through a multitude of grants, including the Heinz Fund for Advanced Sustainable Research and Architecture, the U.S. Forestry Service. Again, those grants are helping push a lot of the United States of America's wood initiatives forward. We have to thank those people at the Wood Forestry Service for their Wood Innovation Grant Program. Also the SITR, a Finland Innovation Fund for supporting the Timber City Initiative. The ongoing research project, Timber City, aims to change the perspective of the architectural potential for urban mass timber technologies. Alan is also a co-author of an upcoming book titled Carbon, a Field Manual for Building Designers, and a recently published paper in the journal, Nature Sustainability, titled Buildings as a Global Carbon Sink. This is a very exciting moment, I think, to see that paper come out. So in general, I think you're getting the gist here. It would be a challenging task to understand the entirety of Alan's body of work and the impact it's made on the natural and built environments. From his teaching to research to design and building, he has a history of and continues to approach the potentials for wood in architecture from multiple perspectives simultaneously. Without further ado, I'm honored to welcome Alan Organschi to the Wood and Everything After Symposium. Sir, the stage is yours.
Thank you, Chris. That was a very generous introduction. I appreciate it. Good evening, everybody. I'm really honored to be here. Thank you, Shauna and Chris, and all your support people who organize this incredible symposium. And I feel very honored to be here. Tonight, I just want to talk about two global landscapes that have historically had a kind of antagonistic relationship. And I'd like to see if we can set the record differently and to sort of explore potentially synergistic relationships between these two landscapes, the forest and the city. And I don't really want to talk too much because I'm not a forester, and there have been many forestry experts here today about the dynamics of forests exactly. And I certainly don't want to talk about urban morphology and organization. Um, what I just want to talk about is what cities are made of. And in particular, what the impact of what they're made of has on the global environment, because we enter this kind of really critical moment in geological history, human history, called the Anthropocene. And we have a lot of questions about that are existential ones. So I confess to having stolen the title of this talk, "What is Wood Anyway?" from my friend and colleague Keel Mo, who asked this question, I'm pretty sure rhetorically, as we were walking down the street in Montreal one day after having kind of heard a kind of discussion on the new product cross-laminated timber. And I think I took Keel's question to mean, and I hope I'm not putting words in his mouth, but I took his question to mean like wood is misunderstood as a building product. And we need to look at it more broadly in a transcalar way. And as he would say, from the molecular to the territorial. So I'm stealing this kind of notion of the sort of transcalar aspect of wood. And it's sort of a way to approach it in a kind of systems thinking method as the subject of my talk today. So we know wood, we know it's a product, and we know that it has certain kinds of properties that make it challenging for contemporary engineering to kind of deal with. And we know them boards and their different kind of appearance grades and things like that, and basic structural knowledge. But as architecture has become more commodified and its process more commodified, we tend to have narrowed our vision of wood into sort of increasingly marginalized ideas about wood, its properties, and its capacities. And we've become sort of distanced from the actual aspects of what wood is and all of its attributes and all of its performance characteristics and all of its potential implications for global health. And those products now have become more sophisticated. We have a whole new host of products called mass timber, which are essentially engineered wood fibers, lamella, and things like that, put together in composite assemblies to produce enormous sections that can now build urban buildings. Products that are particularly effective because they're really amenable to all the kinds of new computer-aided systems for manufacturing, and that they come in extremely large formats, which means we can build buildings really quickly with them. And so these material assemblies can be scaled up into tectonic assemblies, and those tectonic assemblies can produce really pretty big buildings, as recognized by the 2021 IBC. And I won't go into the detail of this, you're probably all pretty familiar with it, but essentially, we can now build buildings that are 3 times as tall as the buildings that were allowable under the old Type 4 heavy timber mason, non-combustible enclosure building type. So that means we can build really tall buildings. And getting back to Keel, what I guess I would say is the tall building and the race to produce ever taller buildings made out of timber just one more product, one more big product that fails to recognize all of the chances and opportunities that face us when we think about using wood globally in construction, and also that we potentially miss all of the challenges and dangers and risks associated with it. And so I think if I could sum it up, I think what Keel really meant was we could really screw this thing up. Wood is a whole host of things. Wood is a molecular lattice that holds carbon, stores carbon molecularly. It's a sort of cellular conduit system for bringing water in and out of the tree and nutrients, feeding it nutrients, which has implications for engineers and also for the experience of wood as a building material and its sort of irregularity and its expansion and contraction due to its hygroscopic nature, its water-loving nature. But that may also be a benefit because wood buildings and wood-lined buildings in particular function kind of like a cigar humidor, where they modify temperature as they absorb and desorb ambient moisture in the air. And how could we possibly understand that better to make healthier buildings and healthier building interiors for all of us who might live in them? And of course, wood is fuel. Wood is a fuel for bacteria and for fungus. And in its digestion, metabolically, it produces greenhouse gases, carbon dioxide, methane. Over half of the wood harvested in the world is used for fuel wood, domestic fuel, industrial fuel. In certain countries, less advanced economies, it makes up 90% of the fuel sources. And of course, it's a fuel for all kinds of wildfires in the built environment, conflagration, and also highly climate damaging forest fires that have run wild, as we know from our friends in California and Australia, Siberia. And these present huge risks. And wood is waste. It's said that up to 30% of the wood that goes into a construction site comes out in a dumpster and goes undiverted into the waste stream. And that's only the construction phase of the building life cycle. That doesn't include the production, use, and end of life phase, which is a startling idea. And so we try to think of wood as part of a circular economy. But if we think of it only as part of a technical cycle, part of the biological renewable cycle, we miss the point that we actually manufacture with wood, and it's very much part of that other lobe of circular economic circuits, which is the technical cycle. And how do we manage material that moves from an industrial waste stream back into a biological end-of-life state, which might be reinforcing global soils? These are really, really complex questions that circular industrial ecologists are just starting to wrestle with. And of course, forests, wood are producers of weather and climate. And at that scale, a forest stand has an important role in creating not only biodiversity, but actually our experience of the carbon cycle and the hydrologic cycle. And in addition to those many ecosystem services that wood and forests provide our planet, we also know that wood and forests are enormous terrestrial carbon sinks. And so that brings me back to this relationship between these two landscapes, the city and the forest. But first, I want to talk about a couple of converging factors that will play an important role in the future of our planet in the next 30 years. And you're all familiar with this, so I'm going to go through really quickly. The Paris Accord set a target of 1.5 degree temperature rise from the Industrial Revolution temperatures 170 years ago. We have 420 gigatons of carbon dioxide that we can potentially emit before we run through that guardrail. Globally, we currently emit 42 gigatons of carbon dioxide per year. And if you're a better mathematician than I, you pretty quickly see that we're going to blow through that guardrail in 10 years. And there are significant implications: mass extinction, inundation of Pacific islands, coastal cities, radical changes in weather patterns that we're already starting to see and are becoming even familiar with, and their potential economic impacts. And not to mention all the political economic upheaval and potential migration that will exacerbate political tensions globally. I don't mean to paint too dark a picture. But the other piece of that is that we are converting forest land at a rapid rate. And the drivers of those forest conversions are the sort of part of our behavior as consumers of consumer goods, including food, agriculture, products that require minerals and fossil hydrocarbons for their manufacture. Where we live, suburbanization has had a huge impact on forest land cover, and climate change itself, producing forest fires, blights, insect and parasitic blights, viral blights that are wiping out forests, weather patterns that are changing, that are changing the forest makeup, and in fact creating forest fires through drought, and our own mismanagement, of course, of all of those factors. So just to put that forest conversion into perspective, the U.S. forest land cover right now, as of before the Western colonists came to start to begin grabbing land for their economic use, in about 1500, forest covered about half of the continental U.S. Today, it covers about 33% of the U.S. Doesn't seem like that much forest loss. But if you consider it as a relationship to the capacity of US forests to sequester US greenhouse gas emissions annually, current forest cover, 33%, can only absorb 11% of the greenhouse gases we emit. And if we were somehow magically to be able to restore and reinforce forests across the country, to bring them back to their pre-Columbian forest cover areas, we would only be able to emit to be able to sequester and absorb 30% of the emissions that we produce as a nation. And so we're fighting against incredible odds, and it's a real uphill battle. Another convergence is urbanization. 2.3 billion people will occupy the face of the earth and move into cities by 2050. Will cover 3 times the current urban footprint if we build human settlement as we currently do. Good news for the construction industry. $97 trillion is the value of that construction that will be required to meet the housing and infrastructural and commercial building needs of that 2.3 billion people who are urbanizing, which happens to be more than the value of the current built environment in total. That's a building, not a city. That's a building with a 53,000 square mile footprint, which is the size of New York State. So from the tip of Staten Island to Buffalo, and from Lake Placid down to Staten Island, we have a building, and that's what we have to build. And with that come impacts. The building sector, so I'm talking about the building sector, industry, transport, industrial extraction, as well as the production and operation and dismantling of buildings. All of that, which is associated with the production of building, eats up conservatively 40% of our emissions budget. In other words, globally, the building sector is responsible for up to 50%, and some would say more, of anthropogenic greenhouse gas emissions. Of that 40%, it used to be thought that because we ignored certain factors, that about 90 or 95% of those emissions were emitted during the operational phase, the use phase of the building. So that from the day that people moved in to the day that they tore the building down, that was where all the energy and water consumption produced all of our emissions. And we didn't think about the fact about that other small percentage of emissions that we mistakenly associated with the production and construction, maintenance, repair, and end of life stages of the building life cycle. But just to put that in perspective, by 2050, 50% of emissions that are coming out of the building sector will have been spent in the embodied phase. That sounds like a weird kind of bit of math, but let me explain it this way. You take an existing building that you're not really doing much to and you're occupying it, and you take a new high performance building that we start building today. The existing building has already dumped its emissions into the atmosphere and will continue in its relatively poor performance to emit carbon at a relatively quick rate over 50 years. The new building, although it performs really well and its flatter emissions will quickly, or not so quickly, but within several decades, match the performance and outdo the performance of the existing building. That new building, that new passive house level building, dumps all of its emissions at the front of the building life cycle. This is exactly the time we shouldn't be dumping emissions into the atmosphere, because we're trying to beat that 2030 deadline. And so the question is not, sustainability efforts heretofore have been all about operational energy performance and thermal insulation and better mechanical systems. And that was all really important, but we better think really quickly about how we use existing materials, existing buildings, because if we don't, what we're going to do is just extract more virgin material and produce more emissions. And so that beautiful carbon cycle, that homeostatic relationship between the biosphere and plant biosphere and the atmosphere and our consumption of products like carbohydrates and oxygen and our emission of CO2 and water vapor has in fact been upended by our work as builders. So we used to build with biospheric products, plants, trees, occasionally surface rock and stone. But over the course of time, we've become more and more sophisticated at extracting more and more energy and emissions intensive materials. And quite literally, we have now dug ourselves into a hole. And we have used up materials that seemed impossible to imagine being used up, like sharp sand, which is now so critical as a resource that it's in fact spawning criminal syndicates in the Indian Ocean, around the coasts of the Indian Ocean, who are dredging for sharp sand to meet the demands in South Asia of urbanization, concrete production, at the cost of 40 gigatons a year. And in so doing, destroying habitats. And the old standard way of comparing material was that we would look at a ton of concrete and we look at a ton of steel and we look at a ton of timber when we think about how much carbon was emitted in the production of those things. And I guess that's fair. I mean, it's fair to compare weight. But in a way, if you think about what a ton of concrete can do structurally versus what a ton of wood can do with much higher, especially engineered wood like cross-laminated timber and glulam, can do for their ton worth of material, you start to realize that we should really be thinking not just about strength to weight ratios, but strength to weight to emissions ratios. And if you add carbon storage capacity into that, obviously wood, which is a biological photosynthetically produced material using sun as a manufacturing energy, it stores enormous amounts of carbon, and it really changes the relationship between how we think about carbon emissions, because actually carbon storage becomes a really, really important part of this equation. And I would say that the term embodied emissions, which comes from embodied energy, is problematic to me because there are tons of embodied, figuratively speaking, emissions in the production of Portland cement for concrete, and in the burning of coke and material for steel. But there's literally carbon in the body of timber. And so we have to be really careful about the terminology we use. Let's just say that as a gross simplified ratio, for every ton of timber we use, we store, depending on weight, species, age, growing patterns, about 1.5 tons of carbon dioxide. So the question is, could this relationship between this forest landscape, regeneratively managed, I definitely want to talk about that, and the making of these big urban buildings out of timber to meet the demand of a growing and urbanizing population, could that be our geotechnology rather than shooting particulate matter into the atmosphere or painting roads white or trying to sink carbon into salt domes below the surface of the earth? Technology is a really challenging problem. Wood is at the forefront right now of technology. It's fascinating what's come of the revolution of nanocellulose. And it's a new kind of technology that we really need to understand systemically. At the nanoscale, we can produce plastic sheets, translucent, and in the future, transparent plastic sheets. We can modify through nanostructural modifications cell walls to make wood more rot resistant, more fire resistant. We can use new adhesion techniques that will use lignin-based glues for adhesion. We can start to study the activation of wood fibers by moisture and how that might become part of a kind of functionality and performance characteristic of the building. We can start to think about this idea of hygroscopicity, not only as just a function of wood getting wet and expanding and contracting, or even better, understanding its moisture buffering possibilities, but also that there may be a thermal mass benefit. It's already been shown by some scientists working in this area that as wood absorbs and desorbs moisture, it actually serves as a phase change material. And so the idea that wood is both conductive and potentially functions kind of like a thermal mass by using the water and its cellular structure is a kind of promising area of energy stability in buildings. But I want to talk about the dumb stuff, the stuff that we all know that exists, that we're manufacturing. And it starts with this little cutter head, a finger joiner, and a bunch of adhesive that hopefully will make less fossil fuel intensive, and reconfiguration of the wood structural member so that we can optimize different grades of fiber in the beam to make them perform better, depending on whether you put the best fibers at the tension and the second best fibers at the compression edges, and you dump not only lower grade, but have potentially different species of wood, which would typically be considered waste wood in a forest harvest, into the center and the cores of the building where the stresses are, the structural member where the stresses are lower. Or as in this case at Bloomer Lehmann in Switzerland, where they built a 5-story timber frame for a Shigeru Ban office building. And what they did was they wanted to use up all the beech wood that was not being really manufactured because it's a difficult wood to work with for those of you who do woodworking. And so what they did, they took the properties of incredible hardness and density of beech, they turned them into laminated veneer plates and dowels. They laminated them into the European spruce structural members, which are incredibly strong. And they produced a steel-free 5-story building. And then, of course, we're working with all kinds of different fibers to try to take advantage, as at the University of Maine in Orono in the center slide, to take advantage of lower fiber quality and how to try to maximize those in different layups. And so I'll just really quickly tell you kind of where I'm coming from, which is that I started as a woodworker. I fortunately met my partner, Lisa Gray, who's an amazing designer and architect and also business mind. And we started a firm that was an architectural professional practice, but it was always had building as a part of its sort of makeup, its ethos. And so we've worked with all kinds of wood. Round wood, these are white oak columns at a daycare center, elevated a story above the playground. Bending lamination, these are twisted stair rail guards that become siding above, interior siding and paneling on above. We've always looked at how wood performs outside, what its provenance is, where it comes from, and also the ecosystem services of the wood that's still in situ as trees plays in shading and providing vapor for a site. But from this kind of artisanal interest, we got really interested in these industrial capacities of laminating timber and how we could try to tweak those and tease apart the commercial configurations of what would become mass timber and use them in different kinds of applications, starting ironically with a bunch of vehicular and then pedestrian bridges and parkland. And then finally, experimenting with this new product, cross-laminated timber, in different ways to produce, in this case, a cupola for a merry-go-round and event pavilion in Stamford, downtown Stamford, Connecticut, or a baseball stadium for a Little League championship field in Staten Island. Or more recently, a product that we did for my pal Peter McKeith in a competition for the new Anthony Timberland Center at the University of Arkansas, which he sponsored. And it was a really great project. We were very happy to submit this entry for a new wood research and technology center on campus in Fayetteville. But this idea of wood as a kind of with bioeconomic potential it kind of came to us through one particular project, the Common Grounds High School, right in sort of outside of downtown New Haven, serving as a public charter school, a bunch of kids who typically don't have access to a program that stresses ecological and agricultural project-based education. And we became really interested in how we could go from this raw state of wood and turn it into these highly processed materials and what the potential impacts of that process would be. And so when we designed this building, they asked us to produce this sort of pedagogical tool that the students could really understand about sustainability, and they wanted to kind of have all the technological bells and whistles, and we put those in. We had daylight analysis with a lot of imbalanced daylight throughout the building to minimize electric illumination requirements, geothermal wells and ground source heat pumps to run the heating and cooling of the building, solar PV, which essentially reduces the operational loads in half for the building. Natural ventilation, stacked ventilation through creating these very high sort of creases in the building envelope. But what we told them was that actually the thing that would be most palpable to the students, because they'd be occupying it all the time, and was potentially the most sustainable aspect of the building, was that if we could build the entire building out of plants, carbon storing plants, And so we started to model all of the different species that were going into the building, understanding their growth rate, their commercial harvesting rotations, what would be an optimum carbon storage rotation, to also understand that 50% of carbon in the forest is in the below ground woody mass and soils. Looking at each kind of species, its transport implications, how much carbon would be stored in the forest, how much would be lost initially through the removal of that, what could be grown back into it, how would we move that material into the building specifically and map that material into the building assemblies and structures. And look below that sort of ground line, you see all of the carbon that is stored and restored in the forest and building synergy, along with the relatively small net emissions that went along with the transport and processing of the building. And so from this small cut stand near Chibougamau, Quebec, through the transport of the material, the manufacture of cross-laminated timber and glulam panels, the assembly of those panels through a secondary processing plant at the Benson Wood facility in Walpole, New Hampshire, its transport to the site, and with 5 carpenters and a crane operator, they built the entire fully insulated, enclosed superstructure of the building in 5 weeks, as opposed to the 3 months that it took to put in the foundations. And so today the building functions not only to as a school place for the school for 250 high school students from inner city New Haven and the region around it, greater metro area, but also 20,000 New Haven residents who come through all of the various programs of the New Haven Ecology Project, which is also housed there. And we replaced fire stairs with glue laminated timber bridges. And we did include steel, but we tried to be really specific about where metals would be used and how easily they would be to recycle or reuse at the end of the building life. And the building is lined with CLT, which is essentially an industrial material in large formats with plentiful daylight washing across it. And there are lots of other kinds of materials, aluminum doors and things like that, of course, and all the lighting systems and the solar photovoltaic semiconductor that's been sintered onto the panels, and lots of drywall. But I will tell you that the students know exactly where, almost like it pinpointed on a map, where that black spruce was harvested by Nordic Structures and manufactured and where it was shipped to. No one, including myself, has any idea where the gypsum was mined for the drywall. And the interesting thing that we heard a lot was that, we're really psyched about the form of the building and its organization and its spatiality and all that. And what a lot of people said to us, and I've said this, and I've heard this from other developers who build out of wood, the building smells good, which tells you a lot, because I don't know about you guys, but I spent a lot of time in classrooms where I felt sick most of the time because of whatever they put into those classrooms when they built the building. And these students somehow felt that the building smelled good. And there have been studies that looked at students who go to school a third of their living day in buildings that are lined in wood and those without. And for some reason, and this may have biochemical factors involved, the students who are in the wood-lined classrooms seem to have lower heart rates and lower cortisol, stress hormone levels. So at the end of the day, the building was something we're really proud of, and it's really great to see over time how the balance of the systems work and where they don't work and how we've had to tweak them and all of those sort of feedback mechanisms, because we have a great relationship with the clients. But we were also really interested in its impacts across the life cycle. And we did a life cycle study, and we looked above the black line, the carbon transect, as I've called it, is this measurement of the impacts and emissions of all of the different components of the building. And so these are things that through the production phase emit carbon. And I'll tell you that the electrical elements, one of the reasons why the electrical elements were such a huge emitter is because of the solar photovoltaic array, which requires a lot of heat and technology to produce. Fortunately, it'll pay itself off pretty quickly in terms of emissions, but it is notable that there is a carbon spike in the production of renewable energy, and that's worth thinking about. As in terms of carbon storage, well, that was all pretty clear. Plants on the site, soils in the site, everything made out of wood, bamboo, pressboard, tecton, all of these kinds of cellulose fiber-based materials were carbon storers. And we also have to give a little shout out to the foundations and concrete, because of course, concrete, as it's exposed to surface and slowly starts to decay a slight bit, mineralizes carbon dioxide in the form of carbonation. For the graphic learners in the group, and I tend to be one of those, if you take apart that building into its constituent components that are associated with a CSI or uniformat kind of like divisions of different building components, we understand the building from a kind of formal and assembly level. But if we remap that so that it reflects actually the role of these components as emitters, we create a kind of monstrous diagram of a gigantic roof made out of cross-laminated timber and timber frame, and then a small bit of internal partitions, which are carbon storers, and then the big emitters like the solar panels that I mentioned earlier. But even a freshman in high school who did this analysis with us knows that this carbon stored in the body of the building is worth an offset of 100 cars' annual emissions. So basically, it's a counterbalance to our tendency to want to emit things. And it's a reliable one because we have the building information systems and models to actually measure how much these buildings weigh. So that's a great story, right? We build buildings out of wood. We should, because wood's good. But it's not enough, given the incredible time constraints we have to solve the problem of climate change, mass extinction, human impact through consumption. It's not enough just to build things with build products out of wood, from toothpicks to suburban houses. This is how we use wood right now. Wood is an incredibly strong material we've seen, right? It's really high strength to weight ratio. And yet we apply it to low rise sprawl. And it is interesting to think that you can tie material density to urban density, and those morphological questions happening at two entirely different scales. And it's particularly interesting to me that a relatively low impact material process, through its harvesting, its moving, its processing, its construction methodologies, produces this really intensive morphology of building the suburban landscape, with all its infrastructural impacts, line transmission losses, the associated with vehicular transport and really inefficient means of that. While these super efficient urban morphologies, which share building envelopes and structure and infrastructure, actually have to use materials that are highly extractive with enormous energy and emissions profiles. So how do we break the relationship between these two worlds? How do we break the relationship between mineral-based material processes and cities, and the relationship between forests, which are photosynthetically derived materials, and dumped into land-intensive morphologies? And we start to see the benefits of carbon storage. Yeah, of course, it takes 20 trees to build a typical suburban house, and it stores 48 metric tons of carbon. You can store 7 times as much carbon and house 40 more families in a building on the same footprint if we build densely. There's no question that we know that. And there's a big question about how people want to live. But if we think about scaling that up to a much larger scale, we really see the benefits. And then the question is, like, how do we move all of this material from suburbia somehow magically, not literally, but in the way we approach building morphology, into dense cities where the storage capacity is enormous? And we do it through these really new material systems that I was a little bit skeptical of in the beginning, which are mass timber and all the other bio-based systems that can be applied to mass timber primary structure. And here's that relationship where, through regional forestry and regional forest dynamics and production, we can break that relationship that happens between the production stage in building, material manufacture stage, and the building use stage. And so we did a study, and we took basically the forest yields in a typical year out of the state of Maine, which happens to be the big mama in the northeastern woodshed, wood production. And we studied about all the different products that could come out of it, their capacities, and we engineered a building. We mapped those building on those components onto it. And so you can see across New England this enormous wood basket, right? And also these demand centers of urban growth, New York greater metro area and the Boston greater metro area. And that includes up to Portland, Maine, and Providence, Rhode Island, and New Haven, our little city, New Haven. And so we looked in New Haven, we started to try to test these principles of building as we did 100 years ago. This is a firehouse where we were asked to add a dormitory for visiting musicians. We'd turn the firehouse into a recording and performance space for regional musicians. And they need more housing because they couldn't afford the hotels in the city. And so they asked us to put a new dormitory on top of an unreinforced masonry building. And what we found was the materials which went up in one day, a prefabricated rooftop sort of penthouse apartment dropped onto the roof in one day, nearly fully enclosed, adding 3 bedrooms and a bathroom to this 8,000 square foot building, actually reinforced the masonry. The unreinforced masonry was not strong enough to take the weight of a typical construction. Stick frame was too flexible and light, not rigid enough. And so by using mass timber, we actually used the new building addition to reinforce the structure of the old building laterally. And I won't go into it in much detail. It's entirely made of wood. It was kind of a test to try to convince regional developers that you could build an interior mass timber building, not have to finish it, and it would be a great place to live. And the musicians who get to live here while they're recording in the studio seem to like it. And it's been a real profit center for Airbnb for the owner of the recording studio. But more importantly, for cities that are struggling like New Haven with a historic building fabric that is generally fairly low rise, 2 to 3 stories, and built primarily out of unreinforced masonry, the idea that you could use the building addition to not only increase density, but solve the problem of structural stability was something that a developer wanted to try. So right there, you see it to the left, the old historic shot of the Firehouse 12, which is now a recording studio, our studio in the middle, those 2 bays, and then beyond that is the Acme Furniture Building. And we added 2 stories to that building, and we put an entire CLT shaft down into the body of the building to lock it into the foundations. And ironically, all the furniture that had been densely stored in that building was heavier than the superstructure that we put onto it. And so now there are number of apartments that are suffused through the building, and we have added, again, a 3rd extra density on that street without destroying the existing building. So the existing interiors feature the brick lining, and the new interiors feature the cross-laminated timber. And that brought us to a new development project, this time for a historically Black neighborhood, an affordable housing project with low-income tax credits, a 70-unit housing project that some of the residents would be at 30% area median income. And the question was, could we build affordably? And so we designed an entirely plant-based building, siding, structure, all CLT, talked to a number of manufacturers, finished the CDs, and we came in at $205 a square foot, which means we have a really good shot at producing affordable housing out of mass timber systems. And that goes down all the way down to the wall assemblies, which use cellulose fiber insulation and acetylated wood siding. And that's prompted a new project in New Haven, which is a historically Black business group is founding in the really one of the damaged areas of the city, an entire new complex, educational residential complex for the city. And this all arises from a study that we did, which was to look at the landscape of a piece of working forest in Maine and a few blocks in the city of New Haven, and to study those relationships between supply from the forest and demand from the forest. And we engineered a series of building types out of mass timber that could fit into all the surface parking lots that existed in the somewhat damaged quadrant of the city. And we looked at the stem succession of the forest stands that we were proposing to harvest, and what kind of different biodiversity and what rates of growth and different species development could happen through the stem succession. So I'll run through this really quickly, but essentially that analysis started with 1,500-acre stand of forest, a quarter of which we left entirely in reserve and harvested in small bits, and transmitting that to 24 acres of urban building over 45 years. And we just started calculating how much carbon would be stored. As we harvested, move that material into the city to fulfill the demands of the New Haven Vision Plan for that particular district, while considering the rate of growth and restoration of those forests and the different kinds of habitat that it would create as they grew. And in the end, what happened was that we found that we actually preserved quite a bit of carbon. We reabsorbed through the photosynthetic activity of the regrowing young forest a huge amount of carbon. We stored quite a bit of carbon, but we avoided even more, almost twice as much carbon by not building out of concrete and steel. And if you start to translate those, in that volume of carbon that is substituted for, avoided, reabsorbed, and transferred for storage into the city, you start to run the numbers of its potential economic implications, especially if we can develop a cap and trade system that includes the value of wood stored in buildings as well as wood grown and maintained in forest land. We can start to imagine not only the old trope of how many emissions were avoided, 65,000 cars worth of emissions, but also if we sort of apply the current value of carbon as a waste byproduct and how much it costs to emit it, and we could turn that over as an offset benefit to urban developers, cities and their jurisdictional authority for urban development. And then we started to actually imagine at the rate at which carbon pollution will, the rate of cost increase that carbon pollution will entail, we start to see that the carbon markets will really begin to reward mass timber if we can learn to durably transfer and store material through regenerative forestry practices rather than extractive ones. So this brings me to kind of the end of my talk, and I appreciate your patience. For our Buildings as a Global Carbon Sink paper, we had a big what if, which is what if we considered this not just at the regional scale, but at the global scale? What if we could create a dynamic in which forests were restored, incentivized to healthy regrowth, afforestation, the expansion of forest cover, the protection of really valuable forests, and use that wood that otherwise would fall in the forest to actually build all of the global demand for buildings infrastructure. So we began to map the forest succession, the carbon storage cycles in the forest. We started to think about how the emissions would look like as we translated that into all the possible products that are already ready at hand and available on the market, and most allowable by building codes. And we looked at low-rise assemblies, and we also looked at high-rise assemblies. And no surprise, because we all passed arithmetic in second grade, the bigger, denser buildings store a lot of carbon. And if we can carefully study exactly how forests grow in different regions and different exposures, we actually might be able to take a really valuable lesson from that natural flux and start to think of new products with new possibilities that would have typically been considered waste wood and bring them into the urban fabric, literally, and gain that storage. But if we're not tracking it carefully, it's just nonsense. It's a fallacy, and we have to be careful that we just don't oversell mass timber as a product. And so we looked at that, and I'll go through this really quickly. We looked at different commercial and residential morphologies, structural spans for primary structure. We looked at the different ways that steel, mass timber, and concrete as primary structural systems could either absorb or emit carbon. And basically, through that study and that arithmetic study, what we essentially found was what was not surprising, that if somehow we could build all that building with mass timber, what we would find is an enormous benefit. I'll quantify that for a second, but just a little proviso. We used different deployment scenarios. And one was to look at the areas of the world which were already had forest product industries intact, ready to go, and that were already producing mass timber. It just so happens that only 10% of global population growth is going to happen in those advanced places. That's just part of the Kuznets curve of socioeconomic growth and benefit. Then we looked at these secondary centers, which are likely to adopt mass timber industries and have fairly robust forest systems. And then finally, we added really the big sort of nut in this equation, which is Africa, which will show enormous population growth and has extremely vulnerable forests. And so we understand that there's a problem of transfer, and we have to address that. And there's a problem of social equity that's really critical here. But just from a numerical standpoint, what we found was that we could actually bend down the curve, accelerating curve of carbon emissions, the business as usual line. We could store anywhere, depending on the different scenarios for deployment, between 3 and 28 tons of gigatons of carbon in 30 years. And that has a significant impact, as biomass projection has a significant impact on our ability to start to mitigate climate change through the built environment, as opposed to just trying to adapt to the climate change, which is going to create more carbon spikes, more seawalls, which will entail the production of more concrete. So we have to ask ourselves, how do we wield our powers as the demand side of a huge equation of consumption? So this brings me to some questions that I'll close with. If we choose to use this tool of buildings as a carbon mitigation, a means of carbon mitigation, we have to ask ourselves, can global forests sustainably supply that demand? Because it would be a real shame if all we did was turn the mass timber industry into a driver of one new extractive industry, harvested wood products. Can we respond more subtly and supplely to the changing dynamics of different forests and different regions? Not only just the high-grade species that we typically grab for building products, but to understand the secondary and tertiary species, the rate at which they grow, optimize carbon, et cetera, and develop new products that might use those, from insulation to membranes to acoustical sound absorbing systems, as well as primary structure. And can the mass timber market and all those other biogenic material markets grow fast enough? Can we convince people to give us the social license to entrust us with the harvesting of trees rather than the deforestation of landscape to build a demand for these products? And then think of all the benefits that come from this. Urban employment, a new sector of building. We're seeing that at our project, at the Dixwell project, the 70-unit housing project that I told you about. For community forest enterprises that could give value to rural populations who are forest sensitive and live near forests and have the benefit of visual feedback mechanisms to know how they're actually treating their forests, and possibly even indigenous populations that have not been able to monetize the benefit of their knowledge and proximity to forests. And can we provide more means to load carbon storing materials into buildings? And then can we ensure permanently that that carbon is stored through cycles of the circular economy, where not only are we thinking about wood as a renewable resource, but as part of that technical cycle, which we can grab and refashion with very simple tools and avoid coating with different plastics and toxic materials so that we can readily reuse them at the end of the building life. And so what I'm really describing is a kind of past and future history of how we have absorbed carbon globally for 350 million years through the rapid uptake of dense atmospheric carbon through woody fern-like plants in the Carboniferous era, and slowly through geological pressure and temperature created fossil hydrocarbons. And then somehow in only 170 years, we found our way to emit enormous amounts of fossilized carbon, turning that into a sort of heavy industrial carbon emissions, which has admittedly given us a huge quality of life improvement, many of us, but with it has come enormous damage. And can we decouple healthy convivial urban space making and consumption to, in some future, create a terrestrial carbon pool, process of its replenishment through all of the different devices that we have at our fingertips. And so I give to you this sort of really positive view of what happened through geological history, what's happened through our more recent anthropocentric history, and what might happen if we use the same technologies that got us into this hole to dig us out of it. Thank you.
Alan, thank you for that talk. As always, it's very informative to hear what's on your mind. And we'll start this off by trying to coax the audience into submitting their questions in the Q&A. And in the meantime, I'm going to try to poke and prod around at this conversation that you've started us on. Today for us, in terms of the symposium, it's been a very, very fast-paced from forest and to your lecture to the city. And it's been very interesting to hear how many kind of cross connections have been made from talk to talk, panel to panel, from this very short period of time, if you will. You've made some very interesting discussion points here about linking the importance of understanding what's actually coming out of the forest, and then what are those products that are getting made in the end, architecture or whatever, that building products or materials, and how they are responsible for a pretty big shift in carbon generation, sequestration, energy demands. And I think it's pretty interesting that some of the stuff that Keel maybe brought up in his talk, and you've referenced in this, about environmental offset in terms of some people benefiting while other peoples are suffering from it, relative to essentially the quality of life question you just ended with. Yes, we are in a better quality of life, but it's coming in at a cost. And I think your questions are really pushing us to interrogate what that new future history is going to be. And that's very exciting. I want to say that it's amazing to hear the idea that you know where every tree comes from in a building, but have no idea where the gypsum comes from, such a ubiquitous material. And as you guys go through the design of projects in your office, or the design build with JIG, or your work at Yale, or the Timber City Initiative, all of these perspectives, can you talk a little bit about how you're educating the people that are around you, whether it's professionals that you're working with, the young people that are even high school age, or maybe even some of the kind of young adults that are at Yale, in terms of what questions to ask in terms of material sourcing, and how those things are going to play an impact on ecological offsets or energy consumptions or carbon issues that we're dealing with?
Yeah, I mean, obviously as a teacher, that's an important question for you, right? I mean, you guys are out there doing it. First of all, I want to say, Chris, that, you know, and I've had this discussion with a lot of my friends in the industry and the discipline. You know, this is, it's hard to practice what you preach, especially in the US, which has fallen woefully behind in its understanding of the dynamics of industry, of material consumption and emissions. And you can look at the European Union as an example of a really progressive, forward-thinking country, which has found all kinds of ways to incentivize the use of biogenic materials and assemblies and buildings through tax breaks and tax credits and things like that, which we're only beginning to see. I mean, with the New Haven project, I will say that through nagging, we finally got the city to give FAR benefits to buildings that are built out of mass timber. And that's why one of the reasons our 340 Dixwell project will get built, because of that benefit. But these are really small steps, and they're coming slowly. And one of the things that Mark Wishney, formerly of the Nature Conservancy, points out is that, you know, we have social license to use wood because people understand it as renewable and healthy, but we don't have social license to cut forests. So there are all kinds of, you know, we've already overcome a lot of the regulatory hurdles. I think people understand that wood is fire resistive and really functions well seismically and all those kinds of things, but we still have a lot of education ahead of us. And frankly, we keep running into roadblocks. My building lab built a coastal research station on an island this summer and tried to do it entirely through circular economics, using a lot of waste material, and it was really hard to put roofing on the building. And there were just a lot of impacts that were associated with the use of concrete, even though we try to use it sparingly. So it's really hard to actually execute. And I think that's where the building industry is, especially in the US right now. We're trying to figure out how to pull this off. So what I would say is we have different orbits of agency. One is as voters, we can vote for people who will bring good policies into the way we act as a society, right? Closer in, we can talk a lot to our clients, of developers, people in the planning departments that we know. And, in the case of New Haven, that's actually proven. New Haven is very forward thinking. It's a city of 170,000 people or something, but, it's actually already starting to think hard about this stuff. But really, the kind of closest ring in is our practice. And that is that we actually are outsized consumers. We think of ourselves as producers, and we're makers, but we're also big consumers, and we drive huge amounts of consumption in the buildings we make. And you know this from your practice because you can weigh your buildings, right? And so do all the people here who are here tonight. And that's our power, because if we start demanding this stuff and we start specifying it and holding the line on this, I think we have enormous power that's, as I say, just much larger than the typical consumer, who is understandably frustrated with trying to bring these sort of ideas to bear. I mean, my students, and I teach high school students, and I teach college and graduate students, and I give lectures on this stuff to my colleagues, many of whom build much larger buildings than I build, with much more sophistication. And we have a lot of discussions about this. And I think the main thing is that what I just mentioned was a kind of disciplinary system boundary, which we have to break. We have to be, as your symposium did today, talking to the forestry sector, the material science sector, the industrial ecology sector, the forest silvicultural sector. We have to be talking on the other side, on the demand side, to building developers, building owners, our neighbors, community-based organizations, city jurisdictional authorities, regulators, policymakers. We orchestrate the built environment because we call on all these resources. So we should be able to make change. And I think personally that the architecture profession has too long marginalized itself, given its enormous power and purview of building. So transdisciplinary, transsectoral knowledge sharing is probably where it starts, in places like this. And then just a dogged pursuit of these things, while really carefully testing it to keep us honest. Because, as Keel and I have talked about this a bunch, and we sound like the nags sometime, in these sort of things. If we don't get it right, it's a dead end. It's over. And I don't mean to put it in so stark terms, but frankly, we're talking about a sixth mass extinction. We're talking about carbon concentrations that there's no possible way can be avoided, given the rate of acceleration that we're seeing. And that's going to, eventually, that has an impact, and we don't even understand the political implications of that. So I don't mean to go on, but I do feel the need to put a fine point on it.
I think your statements are hopefully well received here in this group, and hopefully they start to become pervasive outside the discipline boundaries, as you just mentioned. I'm going to try to go to the question and answer session here to get some of the audiences involved.
Do you want me to stop sharing the screen, or do you want to leave it up?
No, you keep it up there. I think it's great to see some of this work could live on a little bit longer than a lecture. So Ian Wogan had put into the chat the question. He said, who are the critical gatekeepers of stewarding this model into the current state of affairs? And I think you started to touch on it, but it seems like that kind of boundary we're going to have to start to define, or that system is going to have to start to be defined in a much more specific manner or systematic manner. Maybe you can talk about how you're doing that within your network.
Yeah. So Ian's question is fundamental, right? And it's really goes to this question of how to implement ideas that are wide ranging, and the system boundaries of any analysis transcend our professional knowledge base. And I readily admit that I know nothing about forest science. It's sort of what I've learned through the past 12 years of doing research in this area and working with incredible colleagues at the Forest School at Yale and the School of the Environment. And I know very little about industrial ecology and material flow, but I've had to learn that. I think we've narrowed down too much our educational priorities. And I think we have to hold responsible um, schools of architecture and engineering and planning to reach beyond what is really a kind of polytechnic attitude about building education, and really start to teach our students the languages of other disciplines. So the gatekeepers, I think, to answer your question more directly, the gatekeepers are clear. I think I listed them. They lie all along the supply chain, and if one is out of place, if one gate is shut, we start to incrementally lose the capacity to take climate action, for example, or action to solve biodiversity issues, or action to create social equity. All of these things, you can substitute any number of these sort of attributes of human impact for carbon emissions, right? You just substitute it in there. They're basically, placeholders for one another. So those we could, every if you really honestly track the provenance of any material you choose, and you watch who touches it along the way, those people are the gatekeepers, all the way to the building life cycle and hopefully successive life cycles of the materials we put into our buildings. The question is, how do we learn the languages of those people and the approaches and the thought processes so that we can at least be a foreigner in their land who tries to speak their language rather than just a tourist walking around and taking pictures?
Absolutely. I think some of the discussion that came out of the energy carbon with Saul, Kiel, and Ravi actually talked about maybe limiting some of the scales of these production or construction ecologies so that maybe we get a better handle on who is involved and how do we become more accountable for what those processes are and their energy consumptions, carbon generation, those types of things. I think it's interesting. And once you start putting that list of people together, the next thing is to figure out the key components to making sure that the end result is what we need. And then we can figure out how we start to manage those gates, if you will, making sure that stay open.
Yeah, and I think the global economy is a Pandora's box, and neoliberalism is a Pandora's box that we can't close. But what I would say is we can start to focus, on sort of regional regenerative practice, because the question isn't really like how do we reduce harm. It's how do we do no harm, and actually how do we improve all of the ecosystems that we draw upon rather than damage them or nibble away at them.
Yeah.
And that's a hard thing to ask of everything we put into buildings. But buildings, by dint of weight and surface area, have enormous capacities to serve as agents of these things if we get it right. And so I guess I'd say the fundamental question is, how do you focus on your work, whatever scale you're doing, and try to apply some of the principles that we know are just arithmetically problematic, or not principles, some of the factors that are arithmetically problematic in building, so that we can alleviate some of the damage that we do.
Yeah. Another question from the audience was maybe builds on a little bit about what we just talked about. Is there any active research on effectively grafting or holistic use of mass timber to other architects? I think this is maybe about the shared knowledge of practice in some ways. It says, I'm curious how we can even allow for the abuse of non-renewable materials at this juncture and still say that we are designing a building for fellow humans' health and well-being. So I think that there is a question here about how good we are at sharing knowledge, particularly with interdisciplinary.
Yeah, I mean, I don't know. We look at, no knock on the Green Building Council. Thank God they existed for as long as they have, and they've expanded globally to the degree that they have. But if I see one more skyscraper built out of concrete and steel and covered in glass get a LEED Platinum rating, I don't know how to answer that, how to unpack that. And so I'm not taking away from the value of the Green Building Council. It's super important, but they're being asked to try to ameliorate problems that are so profound, and to work within the systems by which we produce buildings that there's so much sunk cost and there's so much resistance to change, and the sector is so slow to modify itself, that I think that we have to kind of, it's got to be a like a shock to the system to think this way. But that the audience member who asked this question is absolutely right. Like, it's really hypocritical to talk about sustainability when we're consuming at the rate we are and not really thinking about our relationship to these remote landscapes and deep lithospheric kind of areas that we're digging into. I had the good fortune of hiking in along just above the North Slope in Alaska for 2 weeks several years ago, and I can tell you that you step from one place to the next, and you're into this world of industrial extraction, and it's really different than this pristine environment. And I don't know how to stop that. I don't know how to do it, but we're part of the problem.
Yeah, I think your analogy of hiking in Alaska, we are hiking. We're hiking through this and trying to figure it out. It is definitely a difficult journey. So one more question that's coming in here is, I think this is actually maybe going back to a little bit of your craftsmanship and knowledge in building, maybe shift gears a little bit. Can you expand on issues of emerging fabrication technology in relation to economy and to builders that may be unfamiliar and hesitant? So to newer ways of wood construction. I think you've been your practice has been something that is worked, I think, from the kind of in-between space all the way from analog to digital and pushing balance in many different avenues, whether it's academic or very practical means and methods. So maybe you can address that.
Yeah, I mean, I guess process is everything, but I think we can get really solipsistic really fast in our profession when we start thinking that the end is the process, the tools that we use, and we fetishize those technologies. When they become convivial tools, they're being used to kind of answer some of the questions that have been raised earlier. So I would say, I would say that what Lisa and I and our great colleagues at Organschi work primarily is by sort of teasing apart the sort of tight configurations of industrial manufacturing. How do you glue laminate something? How do you take advantage of this mass? One of the reasons I'm proud to say that we're able to get the cost per square foot of the building at 340 Dixwell down to the point that it could be considered an affordable construction technology at only 4 stories, is that we worked really closely with our partners in industry, and we know their systems really well, and we were able to optimize their panel lengths and widths and capacities, so we don't have beams. We don't build secondary partitions. They are part of that one assembly system, and so basically our knowledge of not wood per se, that served me really well when I was building furniture and figuring out how not to make a tabletop warp or attach it to a apron carcass. But it does, what really helps is understanding, like, how heavy is it to move a bunch of material and organize it and glue it and press it, and how quickly does it have to move to make it economical, and how many passes do you have to take with your Hundigger, and all of that kind of stuff. And where do robotics or computer numerically controlled machinery do great work, and where are you just dealing with gravity, and that stuff has nothing to do with it, right? Gravity and distance. And so I think really what I would say is the artisanal interests that we had, any furniture maker's interest, is where did this piece of wood come from? Where does it fall in the flitch of the sawn trunk of the tree? What is its relationship to others? Where does the grain pattern fall? How big are the annual rings? How quick were the growing seasons? Those all address stability of wood. We know our processes. We can pick the material up and move it, how to saw it properly, how to plane it, all that we know. The minute we become architects and we distance ourselves from the sort of immediate touch with the medium and the material, that's where we start to, look to legal specifications and warranties and products, systems, and we forget the principles that make building potentially affordable and hopefully mitigative.
Yeah, I think in some ways you get towards the end and we're just trying to stay out of the course. Right,
exactly.
Which is sad, but I think that the other thing you mentioned within your knowledge set here is understanding the tools were part of the process for you to get those numbers down for your project to get built. And almost to the point where, when you said the number out loud, I was thinking that we should all put our earmuffs on because somebody's going to get, super excited about that low construction cost number. But it's very exciting to see that you were able to think through those systems enough to bring that number down to make it sort of reasonably affordable. So
yeah, well, it wasn't just us like inventing it. It was a whole team of people who started from where the wood was coming out of the forest and understanding the grading of it and onward. And I guess what I would also say is, I don't mean to blow my own horn about that. It's a real team effort. And I would also just say that I think that we have a lot of tests in front of us on this stuff. And I think the way to avoid it is to try to get your hands back into the material and your mindset into the makers of that material.
yeah, so we're getting towards the end of your time. I'm sure that you're tired of staring at me on Zoom here, but we still have a strong audience. I have two more questions. I'm going to pose them to you and see if
Sure.
we can do them in some kind of curiosity here. So one of the questions here says, can you speak a little bit about the timber industry? So who grows the trees, who processes them? Are these global companies, unions? Who are the laborers? Now, I know that you just said earlier you're not a forester, and I think that part of the question that's being asked here is maybe you can speak to your particular processes in your region that might help them understand what you have been working with as your team members, if you will, as we look at this as a system of people working to make one task, which is a better built environment.
Yep. Part of this is a sort of extant condition, existing condition, and part of it is aspiration. So I want to be clear about that. One of the things that we think about is the fact that the sawmill industry today is, as one of my colleagues in industry described it, a high wall that we can't see over. We don't know where those trees are really coming from. And there's been a lot of predatory behavior in the sawing of trees. And, FSC tries to do it, but there are there are unintended consequences with different kinds of products and different certifications. Shipping Southern Yellow Pine to an FSC laminator, trees grown and harvested in Georgia up to New York and shipped back because the FSC laminator was the only one who could do it and get the FSC certification for a living building challenge building in Atlanta. And you're just like, okay, I don't think we meant that, right? So there's that side. Like, I would say that mills operating on a sort of low road capitalism basis, where they're just trying to kind of scale production, take the best possible trees, are going to work against our goals. On the other hand, the industry naturally is trying to optimize the resources that it has, because that means better profits. And so if we can develop a kind of more flexible industry, and I'll give a great example of Nordic Structures. My good friend Jean-Marc Dubois, who's the American rep for Nordic and vice president, basically they have little black spruce trees that are 4 to 6 inch diameter. They're not big trees, and they've actually engineered and figured out sawing systems that they can use these really small lamella to produce really, really big buildings. And they're a huge mass timber manufacturer, right? So they've adapted to their environs and the resources, and they know the feedback of the materials, and they're not high grading trees. They're doing really localized shelter forestry and patch clear cutting, depending on the soil conditions and topography. And another shout out to them, half their workforce, or maybe more, are Native Americans from the Cree tribe. And they're really trying to kind of deal with the resources, human and material, that they have at hand, and also they depend on the ecosystems to survive. And then I think the other aspects of industry, we work closely with laminators and with other CLT manufacturers, and there's a sort of complex set of equations around, what tax breaks do you get by using a non-American product, or what tax benefit do you get by using American producers? Is the Austrian producer shipping break bulk but smaller panels, so they're more picks, and so even though their price is lower because their industry is more developed, it costs you more to build the building. Like, all of this stuff along the way, we've found that the mass timber industry is riding this sort of new social license of building with wood to be good stewards of their product. Now, I also have heard stories that there's some Central European forests that are being inappropriately forested for some Austrian manufacturers. And I don't mean to say this in public because these are all rumors, but I just think those are the risks, right? Until we have blockchain custody of every single stick that comes out of the forest, it's going to be hard to manage that. But more importantly, it's not just how much you cut or where you cut, it's actually how you understand the dynamics of forest growth in a particular region with a particular set of species and ecosystems, because in the end, it's not just a quantifiable set of implications. It's about the qualitative ecosystemic benefits that we're trying to promote, and that's a layer of sophistication that will take people far beyond my knowledge base to be able to master.
Yeah, it's. I think some of those questions you were bringing up are processes you were bringing up about small diameter trees and being really nimble with their processing. Actually, was another one of those conversations that came up earlier today, and how maybe industry needs to look at some processes that aren't so enormous in their centralization, but maybe decentralized systems that allow the forest to be leveraged in a way that's more productive for both ends of that spectrum, both the building, processing parts, and the forestry's growth and harvesting cycle. So I think that there's a lot of interest in understanding scale reduction while still increasing its power as a process. So
yeah, I think these systems, I want to make a really important distinction. And I would say that, like, the wood industry is doing really well because they use their waste as fuel, right? So that's right there, pretty amazing, right? And they use all the furnish to produce all these different kinds of wood products that would typically be dusted into the waste stream and off gas methane. What was I going to say? Sorry, I've lost my train of thought. So this is embarrassing. It is getting late, Chris.
the decentralization was what we were looking at in terms of potential reduction in scale of facilities. But
yeah. So the way I try to think about these processes is prototypicality. It's not that that's always the same, but the method by which you analyze and understand can be applied to different systems. Prototypicality is a much more flexible tool, and it's about sort of spreading benefit in a way, right? Scaling is something else. Scaling is like when you're an industry and you want to scale, you want more resources to get bigger and sell more. And that becomes the goal. So I think actually smaller, more nimble industries will be the real thought leaders here. And I think in some cases, small firms that don't have these big gargantuan apparatuses will be real thought leaders as well, because they have a kind of flexibility in the way they think entrepreneurially and the systems that they use and the context that they make. And yeah, it's hard work to be in a small firm, and you can't do maybe gigantic buildings, but what you can do is start to understand these really deep life cycle practices, life cycle and beyond practices of this building process.
So I'm going to ask the last question, and it's by Tom Chung. I think we all.
Tom.
Yeah. I love whenever there's such this kind of connective between everybody. But hopefully, we're talking to people in the audience that are maybe new to this, and we're not just preaching to the choir. So there's good with the bad there. So Tom, thank you for the question. You'll be the last one asking one tonight, so appreciate that. So he also shares sentiment as a hello to you. Wonderful, super informative presentation as always. I could not agree more with him. In creating the new urban environment with wood/mass timber, what do you think is the right density? And I think this is something you started on, and maybe you could probably spend another lecture on at some point. But are we talking about the super tall 40+ story apartments and office towers in Asia as the continuing norm of new urban centers, or limiting the density somewhat to a 12 to 20 story building? At which point does the limit of wood structural capacity outweigh the intense engineering and cost of trying to replicate super tall buildings in wood? What is the right density of the urban centers? I think you began to talk about that when you presented the first building with wood coming out of the treescape, in which you said, is Kiel asking us, are we going to screw this up?
Yeah, of course, Tom's question is deceptively well, it's simple, sounds simple, but it's really complex, and he knows it because he's one of the experts in this field. But I appreciate it. He set me up to close with this. and he and I have had this discussion too. Look, the bulk of building is not going to be in the super tall multi-story buildings. We're already seeing failures of those in Manhattan, those pencil towers, which are starting to break down already. They're barely a few years old. Those are emitters. It's just like we don't need the energy systems that are required, the amount of structure that's required to make a small footprint of that height is not going to get us out of this problem. The bread and butter of most cities in America and probably around the world, and I've talked to industrial ecologists about this and urban demographers at Yale, who I work with, is going to be 5 to 7 stories, right? Higher than what sticks can build with right now, but well within the wheelhouse of mass timber right now. I mean, we know from the 2021 IBC adoption of mass timber that we can build up to 18 stories as long as we cover everything with sheetrock. To me, if I can stay at 9 stories, I've got Barcelona, right? That's the density, and that's a dense city, right? And I don't mean to be sort of retrievalist about this. Like I think the European and Asian cities that I've been that are probably at that height are wonderful. They tend to be more historical because land values are increasing dramatically. We have to find some balance of creating density, removing some of the sort of vehicular infrastructure that we have to put in, all those kinds of things, build polycentric cities so we can get mass transit working, all of the normal things. But to me right now, if we just worked with the technologies that we had in primary structural design, we could build all of that with mass timber. Very few cities, except for cities that host developers who are trying to make showcase buildings that are, over 20 stories, really need buildings of that height. That's what I think. Because I think they're also stop being convivial and they start having cost profiles that knock a huge sector of the population out of being able to afford them. And that's a big problem with urban building right now.
I think you've actually wonderful place to end on, because your statement about cities that are trying to build showcase buildings is precisely the city that we live and work in right now in Miami. We're hopeful for the housing shifts here to maybe allow for wood to service a better chunk of the population, and that is in that smaller range of buildings. So, Alan, I cannot thank you enough for your time.
Chris, thank you.
And your commitment to the discipline of architecture, the education of architecture, and your work towards wood initiatives. It's been a pleasure to witness your lecture tonight and to watch all the things you've been doing from multiple vantage points. So thank you for that. As people are logging off here, I want to just remind everybody, we will start back tomorrow morning with I think a really interesting set of material science questions, and then we'll move towards the projective and retrospective dialogues, which I think will start to address a lot of what was talked about today, ending with Dean McKeith's keynote lecture tomorrow evening. Please send your AA requests to us via the Toro Urbanism Lab at miami.edu's email, and check out the Miro board and that space. We will continue to put updates in there between now and the end of the day tomorrow. Again, Alan, thank you so much.
It's my pleasure. Truly. Good night.
Enjoy, everybody. Thank you.